All right, welcome to Unit 13. This is another geometry unit. Most of the focus of this unit is using and applying the Pythagorean theorem in different situations. So we need to know what the Pythagorean theorem is. You've probably heard of it. It's probably one of the most famous mathematical theorems, named after Pythagoras, who was a Greek philosopher and mathematician. It is used on right triangles only. Right triangles have three parts. They have two legs and they have a hypotenuse. The hypotenuse is always the longest side and it is across from the right angle. So that's kind of like a little arrow that points to the hypotenuse. So A and B are the legs. They're interchangeable in the formula. The hypotenuse is our important part. So we have a squared plus b squared equals c squared. So a leg is a, another leg is b, the hypotenuse is c. So you can also think of it as leg squared plus leg squared equals the hypotenuse squared. Okay, so let's look at this. So it says find the length of the missing side, round answers to the nearest tenth. So we have a 10 and a 5. Those are both legs. So we're going to set this up as 10 squared plus 5 squared is equal to c squared, or you could call it x squared. It doesn't really matter. So when I do this, I go ahead and I just do 10 squared plus 25 or plus 5 squared. So that's 125, and that's equal to c squared. Square root that, and so c is equal to 11.2 because we're rounding to the nearest tenth. And even though we're taking the square root and we are in an equation, we only need the positive one because we're looking for a distance, and distance is a positive measure. All right, example B, we have 3 and 8. Those are both legs again. So 3 squared plus 8 squared equals c squared. Again, I can go ahead and type those in my calculator, just 3 squared plus 8 squared. Or do that math in my head. So 9 plus 64 would give me 73 equals c squared. Then to solve for c, I would undo the squaring by square rooting. C is equal to 8.5. All right, this time we have the hypotenuse and a leg. So we're missing a side. So we could say a squared plus 2 squared equals 4 squared. And typically, if we leave these in exponent form, when we move them around, our numbers are going to be smaller and easier to work with. So I usually just leave them in exponent form and then do the calculations in my calculator. So 4 squared minus 2 squared would be 12. Then I would square root. So my leg that I'm missing is 3.5. Example D, those are both legs. So 6 squared plus 6 squared would equal c squared. So that would be 72 equals c squared. We would square root both sides, and c is about 8.5 when we round to the nearest tenth. Example E, we're missing a leg. We'd call it B if we wanted to, but a squared plus 8 squared equals 10 squared. Subtract 8 squared, so a squared equals 36. Square root, and a is a perfect square of 6. This time we have a hypotenuse, we're missing a leg, so let's do 2 squared plus b squared equals 7 squared. Subtract that 2 squared, and b squared is equal to 45. Square root, and b is 6.7. We're not always given a picture. Sometimes we're just given the side angles. So 15 squared plus 18 squared equals c squared. We add those together. We get 549 equals c squared. Square root both sides. That's 23.4. A squared, we don't know, plus 6 squared equals 12 squared. So a squared is equal to 108. Square root both sides. A is 10.4. Now I know I'm going really fast with these. I actually did these previously, so I'm not typing these in the calculator right now. You can always verify my math if you want. All right, so we're going to subtract 3.3 squared. So b squared would be 22.75 square root, and b is about 4.8. Okay, so now we're really good at the Pythagorean theorem. Let me introduce you to the converse of the Pythagorean theorem, or kind of like the opposite of the Pythagorean theorem. So the Pythagorean theorem states that for every right triangle, a squared plus b squared has to equal c squared. So the converse of the Pythagorean theorem would be that if a squared plus b squared equals c squared, then it is a right triangle. And we can extend this a little bit further and use it to classify whether we have a right triangle, an acute triangle, or an obtuse triangle. C is always going to be the longest side of the triangle. So if we're given side measures, we just have to take the two smaller sides and square them, and based on that answer compared to the longest side squared will depend on whether it's an acute or an obtuse triangle. So if c squared is bigger than the sum of the squares of the legs, or the shorter sides, it's obtuse. If the sum of those is bigger than c squared, then it's acute. So we're just going to be looking basically right there. All right, compute the sum of the squares of the shorter two lengths. So 8 squared plus 11 squared is 185. And then the longest side in this case is 12 squared, so that's 144. So our longest side, so our c squared, is less than the sum of our shorter two sides, making this, well, I said that backwards. This is an acute triangle because the sum is bigger than the longest side. All right, here we go. We have another triangle who has sides 18, 15, and 7. So we're going to take the two shorter sides, square them, and sum them. So 274. And then we're going to take the longest side and square it. And we get 324. So that sum is less than that third side, making this an obtuse triangle. Good luck.